Have you ever wondered how your computer communicates with a distant server when you browse the internet or access an online service? Welcome to the fascinating world of client-server architecture, a cornerstone of modern computing and network systems. It's like a dance between two key entities, clients and servers. Clients, which could be your desktop computer, laptop, or mobile device, initiate requests for services or resources. They rely on servers to fulfill these requests. On the other side, servers are specialized computers or programs that respond to these requests, providing services, resources, or data. Whether you're sending an email, streaming a movie, or accessing a cloud-based application, you're engaging with a client-server architecture. From operating systems to web applications, this architecture underpins the way we interact with the digital world. So let's put on our explorer's hats and delve deeper into the intricacies of client-server architecture. Stay tuned as we delve deeper into the intricacies of client-server architecture. Let's start by understanding what clients and servers are in this architecture. Clients and servers are the key players in a network system. They're like dancers in a duet, each with distinct roles but working in harmony to create a seamless performance. Picture a client as a user device or a software application that initiates requests. It could be a desktop computer, a laptop, a mobile device, or even a software program running on these devices. When you open a web browser and type in a URL, for instance, you're acting as a client, sending out a request for a particular web page. Now imagine a server as the partner responding to the client's request. It's a specialized computer or software program that provides services, resources, or data. Servers are the heavy lifters in a networked system, designed to handle multiple client requests simultaneously, reliably, and efficiently. They're the ones who make it possible for you to access your emails, store files, host websites, and so much more. In this dance, clients and servers have their unique roles. Clients depend on servers to provide specific functions or data. They're the ones who ask, "Can I have this?" Or "Can you do this for me?" The servers, on the other hand, are there to answer these requests, saying, "Here you go," or "Sure, I can do that for you." They offer various services such as file storage, database management, web hosting, and application processing. However, it's important to note that not all clients and servers are created equal. Some clients may be more demanding, requiring more resources or services, while some servers may be more powerful, capable of handling more requests or providing more extensive services. But no matter how diverse the clients and servers may be, they all follow the same principle in a client-server architecture. Clients initiate requests, and servers fulfill those requests. It's a continuous cycle of asking and providing, all to ensure that our networked systems function smoothly and efficiently. In essence, clients request and servers provide. But how do they communicate? Communication is key in a client-server architecture. But how does it happen? Well, it's all about protocols. Specifically communication protocols such as TCP/IP, HTTP, FTP, or RPC. Think of these protocols as the language of the internet, enabling clients and servers to understand each other. TCP/IP, for instance, is a suite of protocols that governs how data is sent and received over the internet. HTTP, on the other hand, is used for transmitting hypermedia documents like web pages. Now, let's focus on the actual communication between the client and the server, which follows a request-response model. This means that the client initiates a request, like asking for a web page or sending an email. The server then processes this request and delivers a response back to the client. It's like ordering a coffee at your favorite cafe. You, the client, place your order with the barista, who represents the server. The barista then makes your coffee and hands it over to you, completing the request-response cycle. But it's not always just one server handling a client's request. In a busy network, multiple servers can work together to handle multiple requests from multiple clients, all at the same time. It's like having a team of baristas working together to serve a bustling cafe full of coffee lovers. That's how clients and servers converse. But what fuels this communication? Operating systems are the engines that power our devices. But how do they work in a client-server setup? Let's dive in and explore. Just like in vehicles, different engines serve different purposes. Similarly, in the realm of operating systems, we have client-side and server-side operating systems, each designed to perform specific tasks. Client-side operating systems are like the engines in our everyday vehicles. They power devices that we interact with daily, such as desktop computers, laptops, smartphones, and tablets. These operating systems provide the user interfaces and application support that enable us to interact with software applications and access network resources. Think of Microsoft Windows, macOS, Linux distributions, Android and iOS. These are all examples of client-side operating systems. Now imagine a freight train. It requires a more robust and powerful engine to pull heavy loads. This is the role of server-side operating systems in our analogy. They're designed to handle heavy-duty tasks like managing network communications, providing services, and managing resources. Server-side operating systems are optimized for stability, security, and performance, making them perfect for a networked environment. Examples include Unix and Linux distributions, Microsoft Windows Server, and other specialized server operating systems. The roles of these two types of operating systems in a client-server architecture are complementary. Client-side operating systems send requests for services or resources to server-side operating systems. The server-side operating systems then process these requests and return the desired services or resources back to the client-side operating systems. This interaction follows a request-response model, creating a dance of data that keeps the digital world turning. In summary, client-side operating systems provide the interface and application support for user devices, while server-side operating systems handle service provision, resource management, and network communications. Together, they form the backbone of the client-server architecture, powering the digital interactions we engage in every day. These operating systems make client-server communication possible. But what makes this communication seamless? Tune in to our next scene to find out. Middleware, scalability, and security are crucial in a client-server architecture. But why? Let's start with middleware. Middleware is like a translator, a piece of software that serves as a go-between for different applications, allowing them to communicate with each other. It's the unsung hero in the client-server model, ensuring that different systems can talk to each other seamlessly. Imagine you're in a foreign country, unable to understand the local language. Middleware is like your trusty interpreter, translating your words so you can interact with the locals. It provides a layer of abstraction and standardization, making it easier for various software components to work together, even if they're written in different programming languages or running on different systems. Next, we have scalability. In the world of client-server architecture, scalability is king. It's all about the system's ability to handle increasing workloads. Think of it like a well-oiled machine that can ramp up its capacity when things get busy. So when more clients make requests, the server doesn't buckle under the pressure. Instead, it spreads the load across multiple servers, ensuring that everyone gets the service they need. This is where load balancing comes into play. It's the equivalent of a traffic cop directing client requests to different servers to ensure no single server gets overwhelmed. Techniques like round-robin scheduling, weighted distribution, or dynamic routing are used to distribute the load efficiently. Finally, let's talk about security. In this digital age, security is paramount for any system, and client-server architectures are no exception. It's like a fortress, protecting the integrity and confidentiality of data. It's all about safeguarding the system from unauthorized access and potential threats. Encryption is used to scramble data, making it unreadable to anyone without the correct decryption key. Authentication verifies the identity of users, ensuring only authorized individuals have access. Firewalls act as gatekeepers, controlling incoming and outgoing network traffic based on predetermined security rules. And let's not forget intrusion detection systems, which monitor the system for any suspicious activity. In conclusion, middleware, scalability, and security are like the three musketeers of the client-server architecture. Middleware facilitates communication, scalability ensures the system can handle increasing demands, and security safeguards the whole operation. Each one has a vital role to play, and together, they form a robust and efficient system. Security, scalability, and middleware are the pillars that support the client-server architecture. So we've navigated through the world of client-server architecture, but what have we learned? We've seen that client-server architecture is an integral part of our networked systems, involving two key players, clients and servers. Clients, whether they're devices or software applications, initiate requests for services or resources, Servers, on the other hand, are the reliable and scalable entities that respond to these requests. We've delved into the intricacies of communication protocols, understanding how they facilitate interaction between clients and servers. We've explored both client-side and server-side operating systems, each with their unique roles and characteristics. We've gotten to know middleware, the unsung hero that ensures smooth communication and interaction across diverse systems. We've also learned about scalability and load balancing, key to maintaining performance as demand grows. And we cannot forget about security, the critical shield that protects our data and systems. Understanding client-server architecture is key to appreciating how our digital world functions. Thank you for joining us on this journey.